Hey everybody, Mr. Dickin here. In this video we're going to kick off Unit 3 talking about polynomials and exponent properties. So the first target we're going to talk about is just classifying polynomials. And the way we classify polynomials is done using two criteria. The first criteria is going to be something called the degree of the polynomial. And the degree of the polynomial just basically means, do I have a plain old x or an x squared, x to the third, x to the fourth, x to the fifth, so on and so forth. It could even, apply to if we just had a plain old number. Now, each one of these scenarios gets its own special term. If we have just a plain old number, that's referred to as a constant polynomial. If we just have a plain old x, we would have something called a linear polynomial. If we see an x squared, and that's the highest exponent, we would have a quadratic. If we see an x cubed, x to the third, we'd have a cubic. X to the fourth is a quartic. And x to the fifth is a quintic or quintic, depending on how you pronounce it. So depending on what the highest exponent or the highest degree we see in a polynomial will determine one way that we can name these polynomials or classify them. The second way we can name them is by the number of terms. So the number of terms. Now, if we have something that is just one single term, so I'm making this up, 7x to the third, that's what's called a monomial. Mono means one, and then nomial is a Latin-based term for numbers or numeration. If we had two terms, again, making this up, 8x to the fifth minus 2x squared. If there's two terms, that's called a binomial. Three terms, let's go 8x to the third plus 2x minus 1. Three terms would be a trinomial. And then anything four or more would be a poly. Poly meaning many. Polynomial. So the way we can classify these is by their degree, meaning the highest exponent we see on the x variable, and the number of terms. So now let's get into some examples here. Based on these examples, we want to do a few things. We want to identify or classify the polynomial given to us. We want to write it in standard form, and then we want to identify the lead coefficient. So let's first identify the type here. To identify the type of polynomial, I need to know what is the degree and how many terms are there. Well, to find the degree, I'm going to look for the highest exponent. So the biggest exponent I'm seeing on the x variable is 4. So that means I've got a quartic function. And if I count the terms, I've got 1, 2, 3, 4, 5. Well, that's several, so I'd have a quartic polynomial. Quartic polynomial. Then we're going to write this thing in standard form. Now, standard form means that we have to write our exponents in something called descending order. Hopefully I'm spelling that right. Descending order. And essentially, we just need to make sure the highest exponent comes first, and then we kind of count our way down from there. So if I take this polynomial, I'm going to look for the highest exponent term. That is negative 8x to the fourth. That has to go first. So negative 8x to the fourth is the first one up. Then I'm looking for an x to the third. Here we go. Negative 2x to the third would come next. Next in line, if I go x4, x3, next up would be x squared, x to the second power, positive 7x squared. Next up would be plain old x's. I've got a positive 5x. And then lastly would be my constant, or the number that does not have an x attached to it. In this case would be 5. So this is now written in standard form. Typically, we like things to be written in standard form because then it becomes much easier to identify what is that degree exponent. All right, and then lastly, we have the lead coefficient. The leading coefficient is the coefficient attached to your leading term when written in standard form. So in this case, our leading coefficient is going to be -8. Now down the road, when you start graphing things like this, you really only care about positive or negative when it comes to your lead coefficient. All right, let's see another one. Number 2, we have 10 plus x squared minus 2x. I'm actually going to go ahead and skip straight down to standard form. I'm going to do that first because I find once I have it in standard form, it's much easier to figure out the type and the lead coefficient. So standard form, the highest exponent I'm seeing is at 1x squared, and then -2x, and then a positive 10 to end it out. So now that it's in standard form, I can see there's an x squared. X squared, if I go back to my list, let's see, x squared is a quadratic. So I have a quadratic term, and we have 1, 2, 3 terms. So I have a quadratic trinomial. We have a quadratic trinomial. And then the lead coefficient would be just a 1, because there's technically a 1 attached to the x, even though it's not written. All right, next one. This one's kind of different because we have multiple variables. Now, because we have multiple variables, we don't really use the special degree terms like linear, quadratic, cubic, quartic, things like that, because these all depend on, if there's just one single variable, typically the letter x. Well, if I look at example number 3 here, we have an x, we have a y, we have a z. So we can't really call this, it's not a linear function because the x has an exponent of 1, because what's going on with these z's and the y's? We can't really call it a quadratic because that's going to focus on one variable. What we can do is we can still identify what this degree is by combining all of the variable exponents. So we're going to have, let's see, I have z squared, that'd be x to the first and y to the fifth. And I'm counting one single term here. So what I could say is that this thing is a monomial, because there's one term. And it's got a degree of, let's see, 2 plus 1 plus 5. Oops. That would be 8. So a polynomial degree of 8, or of the 8th degree. Again, it's not going to get a special name, but we can still identify the degree here. Standard form, we're really not going to change a whole heck of a lot. Typically with these, you want to write your variables in alphabetical form. So x, y, z. Typically that's going to be the mathematical convention. Occasionally there will be times where you might see maybe the highest exponent comes first, but normally we like to see just the same order of variables because that becomes a lot easier for us to identify like terms down the road. And then lead coefficient, that is just the constant number attached to all of your variables for the first term. Luckily for this one, there is only one single term to worry about. All right, so that is it for this video. In case you did not get it written down, I'd strongly advise getting this jotted down somewhere in your notes. Take a picture, take a screenshot, so that way you have that for your reference. You know the drill. If you have any questions, please let me know. And as always, good luck, have fun, be safe, roll tide.